to start on the basics of Java. We're going to start on the basics of Java. What is Java? And then you are going to learn the basic Java programming language. After that, you learn object-oriented programming using Java. So this module is about object-oriented programming, but you'll be using Java programming language. So you need to know the Java programming language first before you actually understand object-oriented programming concepts. Why? Because for you to be able to understand them, for you to be able to use those concepts, you'll be using the Java programming language for this module. So let's look at Java programming language. I'm going to put this slide in presentation mode. Guys, it's advisable to join earlier. It's advisable to join earlier so that you do not disturb the progress. So let's look at this is, so I just need the highlighter. I need a highlight. So if you look at it, this is object-oriented programming, but you are going to use the Java programming language. But the module is what is object-oriented programming. So let's look at what is Java and why we need Java. Maybe in 2024, why do we still need to learn Java? So Java is general purpose programming language that is concurrent, class-based, object-oriented. So the first thing, suppose the concept of concurrent. Also, it is class-based, which means everything in Java is class, or it is the concept of classes. Also, it is object-oriented. So it is intended to let application developers write once and then run anywhere. So it supports the concepts of water, the concept of water, meaning that compiled Java code can run on all platforms that support Java without the need for recompilation. This is also the very important aspect of Java. If you write it maybe for Windows machine, you do not need to rewrite the program for Linux machine. You just need to have what you call the Java runtime environment for Linux, and then the program will be just the same. You just run that program on Linux machine. So you just write once and then run anywhere. So Java is platform independent language, which is also the very, very important thing. It is platform independent language, which means if you just learn Java once, you do not need to learn it for any other platform. It means it can run on any platform. So it is Java virtual machine as well. It is what we call the Java virtual machine, which is a machine which doesn't exist. It's a virtual machine. It's just like a physical machine, but only that this one it doesn't exist. It's not a physical machine. It's just a virtual machine. So you just write the code for this machine which doesn't exist, which means whenever you are going to run your program on any physical machine, it is going to run without actually looking on the issue that you have used you have wrote this program maybe for Windows, or you have wrote it for Linux. Why? Because you'll be targeting this virtual machine which will be on any platform that you'll be using. So it is an object-oriented programming language, which is also the very thing, the very, very thing to take there, that it is object-oriented programming language. Why is it good for us to say that we are learning Java? Because it is object-oriented programming, because it supports the concepts of objects. So if it is supporting the concept of objects, you need to know that this language needs to solve real-world problems. And in real world, we've got objects. So if it is object based, it means that it can effectively solve our our real world problems. Remember, I as a person am an object in real world. So it means it can support the object of a person. So it can have the methods and whatever to deal with the problems that a person needs to solve. So because it is an object-oriented programming language, then is something that you need to learn. And then let's look at how to run a Java program. If you want to run a Java program, how are you going to do it? first things first, you need to have what you call an IDE, which is you need to install what you call an integrated development environment. That's the first thing. Maybe you're going to use Eclipse. There are a lot of IDE that you can use. So you'll be using the Eclipse IDE, but you're free to choose any IDE that you can use for this module. You're just free to choose. And then you can install the Java development kit. There's what you call the JDK. You need this JDK for you to be able to run the Java program. You're going to talk about these things later, because sometimes you do not need the Java JDK. You might need the Java runtime environment. So if you're a developer, you need the Java JDK. For you, you need the Java JDK, because you are going to develop this. You're going to develop softwares using Java. After that, you can write your Hello World program. So it is very, very simple, guys, to have this. Okay, let me just this was all about the basics of Java. This was all about the basics of Java. So okay, I just need maybe I can do this. I need the Google Chrome. Okay. So if you go here, if you say Java JDK, so this is where you can download your Java JDK, and then you install. If you look at it for the Java 21, but you can go for the stable version, or the Java 23, the latest one. So you can go for Java 21 or Java SDK, Java 17. You can download even Java 17, and then after installing this JDK, then you need the IDE Eclipse. Maybe if you go for Eclipse IDE here, you can just say Eclipse for Java, and then you download your Eclipse, and then you install. Or you can just download the Eclipse and install. During installation, if you say this one is for Java, it will actually ask you to download the Java JDK. And then after that, once I've already done this process, I am not going to download anything. Then after that, you are going to have your Eclipse ready for you to develop the projects. So maybe I can just create a new Java project. This is how you can create a new Java project. And then maybe I can say demo here. It's already there. Maybe I can say hello demo, just like that. And then I'll click finish. I'm just creating a project in Java. After that, I'll create what I call a class. Don't worry, guys. You are going to learn about this. You are going to learn about. So let's look at now you can create what you call a class. Maybe I can say demo here for this class, and then I'll put the main method. You know, we have been calling it main function. So after this, oh, I've got an error. I think it's the issue of package. I forgot to put, let me just put a new package. Let me just say demo. Let me finish, and maybe I can take this one here. Let me see. Okay, yeah, the error is gone. So here I can print out system dot out, maybe dot print, maybe line, and then hello Java, just like this, and then I can run my program. So guys, this is how you can do it. We are going to talk about this later. What are these classes? How can you do this? We're going to talk about this later. But it was just a demo on what you can do if you want to write a program Java, a Java program on your machine. You need the IDE. This is what we call the IDE. If you look here, it's Eclipse IDE. So it's just like a text editor. When you're doing C programming, you would need dev C++, maybe you need what? There are a lot of IDEs that you can use. So for Java, you're going to use Eclipse, but there are a lot of IDEs that you can use for Java. Feel free to choose anything that you think you are comfortable with. Guys, you are not restricted to use only Eclipse, but for all my videos, I'll be using Eclipse. Then let's look at how Java works. This is a very, very important part so that you get to understand how Java works. After that, maybe you'll be able to develop the programs very easily. So let's look at how Java works. Let me pick the green ones. Okay, so let's look at components of Java. We've got components of Java. What are these things? We've got what we call the JDK, which is the one that I've said you need to download. If you want to develop a software using Java, you need to download this, what we call the Java Development Kit, which is the Java JDK. So I'm going to talk about this Java JDK. What is it and how does it work in Java? And then there's this what we call the Java Virtual Machine. Don't worry, you do not need to download this. It comes with this Java JDK as well as with the Java runtime environment. So there's what you call the Java runtime environment. We are going to talk about this later. But normally this one is for your clients. After you develop a software, you need to give your clients what you call the Java runtime environment so that they'll be able to run your program, right? So let's look at what we call the Java Development Kit. So it is a software development environment used for developing Java applications and applets. So it includes what we call the Java runtime environment, which means in this Java JDK that you're going to download, there's also this thing that we're going to talk about later, which is called the Java runtime environment. Also, there is an interpreter, a compiler, an archiver, a documentation generator, or the Java doc, and other tools needed in Java development. So I need to add someone here. Okay, I'm sure they're already in. So this is what you call the Java JDK. So it is a software development environment. So this is where you write your code, right? This is where you develop your code using this Java JDK. So this Java JDK is equipped with everything that you need from writing the code, from testing the code, and debugging the code as well. So let's look at how this JDK functions. So if you look at it in general, we've got this JDK. So everything in here is what we call the Java JDK, which is the Java Development Kit. If you look at it, inside this Java JDK, we've got what we call the JRE, or the Java Runtime Environment, which is part of this JDK. Remember, I've said before that if you have already developed your software, you do not need this Java JDK. You need the JRE to run your software. So the JRE is also in the JDK, so that after you code your software, you can test it. You can test it how? By running it. So that's why we've got this Java runtime environment inside the JDK. So we have for this JVM, which is the Java Virtual Machine, which will be inside the JRE, as well as the class libraries. These class libraries, they are just like those that you have been writing in C programming. Those header files, hash include, stdio.h. These are what we are talking about as class libraries. These are classes which have been already done in Java. And excuse me. And after that, we've got what you call compilers, debuggers, and the Java doc. So this one is for you to be able to create Java files. It's for you to be able to create Java files. And then for debuggers, for you to be able to debug, and then compilers for you to be able to compile your program after you wrote it. So the IDE is there for you. It will be acting as a text editor, and it will be connected to the Java JDK. So you'll be writing on a text editor, which is the IDE. After that, like the Eclipse that you're talking about, after that you submit it to the Java JDK. Then the Java JDK will test for you, right? It will compile and test for you, and then you can debug, something like that. So let's look at what we call this Java JDK. So this what we call the Java JDK, and then the JRE have been actually already explained. So the JDK enables programmers to create core Java programs that can be run by the JRE, which include the JVM and class libraries. These class libraries have been explained on them. Then the compiler is for you to be able to compile those class files that you have in Java, and then it will give you a bytecode. So it is a Java program that accepts text file of developers and compiles into Java class file. So it is the common form of output given by compiler, which contains Java bytecode. So in Java, the primary compiler is Java C. This is the one that you use to compile your code, right? And if you look at it, it will give you what you call the bytecode. This bytecode is the one which is almost closer to the machine code, but this bytecode is the code that can be understood by this what you call the Java virtual machine. So this Java virtual machine is the one that you'll be actually talking to the what to your operating system, something like that. So these debuggers, they enable you to be able to debug and test your Java program, and then the Java doc is for you to be able to create the Java files. Like what I've done, I've created the class code demo, so this is the Java doc that will be helping me to create all those documents, right? Then let's look at what we call this Java virtual machine. This machine that we have said it's there, but it doesn't exist. So the Java virtual machine is an engine that provides a runtime environment to drive the Java code or application. So it converts the Java bytecode. So after you compile using your compiler, the compiler will give you the bytecode. So this bytecode is the one that is being converted by the Java virtual machine into the machine language, which means this Java virtual machine is like an interpreter of the Java code to the operating system or to the to your machine, just like that. So that's why we are saying Java is platform independent. Why? Because you write your code for Java virtual machine, and then this Java virtual machine will convert for your what? For your operating system or for your machine or for your physical machine, just like that. So any code that you're going to write is going to be interpreted by the Java virtual machine. Okay, so JVM is also a part of the Java runtime environment. That's why we have said that here in JDK, you have got the JRE, and inside the JRE, you have got the Java virtual machine. So it means the Java virtual machine is part of the what? Of the Java runtime environment. So let's look at this Java virtual machine. What happens here? If you look at this concept of write once and run anyway. If you look at this, we've got the Java program that you have wrote, maybe the Hello World or the Hello Java that I've done. I've done it on my Windows machine, right? But this code can run on any platform. Once if you have got the Java virtual machine for that platform, it means that this program, it doesn't need to be recompiled. Once I've compiled it on my machine, it can run on any machine if we have the Java virtual machine installed on that machine, right? So if you look at this Java program, for it to run on Windows OS, it needs the Java virtual machine for OS. Then for it to be able to run on Linux OS, we need the virtual machine for Linux OS, the same for Mac OS. So Java is platform independent. So it is one of the points that we actually learn Java by this point in 2024. You can actually enjoy this. You just write once and you can run it anywhere. So what is Java runtime environment? Let's look at JRE. So it is software that Java programs require to run correctly. So if you want to run any Java program, you need the JRE, not the JDK. The JDK is for those who are going to create softwares. So in simple terms, if you want to run a Java program, you need the JRE, you need the Java runtime environment. So if you are not a programmer, you don't need to install the JDK, but just the Java runtime environment to run your Java programs, just like that. So that's what you need. So how does this Java runtime environment functions? How does it function? So we have got what we call the class loaders. Remember those classes that we have said they're already done in Java. Maybe you just want to import them and then you use them during your program execution. Like what you've done in C programming, you could have the hash include stdio.h for you to be able to use the printf, the scanf functions. So it's just like that. So here in JRE, we've got what you call the class loaders to load the various classes that are necessary for running your Java program. After that, we've got the bytecode verifier. This bytecode verifier, remember we've said that we've got the Java virtual machine, which is inside the Java runtime environment. So we need to verify the bytecode first before we give it to the Java runtime environment, to the Java virtual machine. So this bytecode verifier verifies the bytecode so that the code doesn't disturb the interpreter. And then we've got the interpreter now. Once the classes get loaded and the code is verified, the interpreter reads the code line by line. And after that, we've got the runtime, which is now the program is now in execution. And after that, we've got the hardware, which means now the program is now runs on that hardware, communicating with the hardware, doing what you want to execute. So normally this is what you call the Java runtime environment. This is what we call the Java runtime environment. So let's look at how does Java programming language work in short. Let's look at how does it work from the very first moment you create your program to the very end moment you see your program running, right? Like if I come here, you want to see from the very moment I created this project until I run this and see the output. What is happening? How does it work? So if you look at that, first things first, right? You are going to have this program .java. Normally these are classes. If you look at it, I've got this program like demo.java, which means this is a file, or if this is a file, I've created a class called demo. So this is a file with a class called demo, right? So after that, I wrote my code, which is all this code. So after writing all these lines of code, I'm going to give it to the Java compiler. So that's why you see that whenever I run this, it will first compile and then it will run and give me the output. So I'm going to give it to compiler. And then what does compiler do? The compiler actually compile the code and give us the bytecode. So at the end, it will give us program.class. So I'm going to have what we call demo.class after compiling. This is what I'm going to get, the demo.class after compiling. And then that demo.class or program.class is what we call the bytecode. And that bytecode is the one which is going to be given to the Java virtual machine. And then the Java virtual machine will convert to what? You convert to the machine language, and then the program will run on my machine. After that, I will see the output being given to me by the system, just like that. So these are step-by-step program execution in Java, from the way you write the program until it executes on your machine. So this is how the Java program actually work. This is how Java programming language work. I don't know if I've got some questions on this one. I'm sure this is the last, this is the end of our slide on how Java works. I don't know if I have questions on this one. I'm sure I can go on to the next slide. If there are no questions, even contributions are welcome. It seems that everything is well unshakable. Let's look at Java variables. There's what we call Java variables. I'm not going to waste much of our time on Java variables. Why? Because I know you've been doing many programming languages. You've done C, you've done C++. I'm sure you are doing C# as well. You are doing Java. You have learned a lot on variables in general. So these Java variables, they're not different from any other variable that you know. Like we can talk of variables in C, we can talk of variables in C++. They are just like variables in Java. Maybe a very little demo or a very little things that you need to know about these Java variables. Otherwise, what the information that you have is enough. Also, one of things that I can tell you is that Java itself, Java programming language itself, it was built on C++, right? So any code that you can write in C++, it's almost like the same code that you can write in Java. Maybe the environment is the one which is just changing, but otherwise, Java was actually developed on what? On C++, right? So if you've learned C++ before, Java is not going to be something which is hard for you. So let's look at Java variables. What are these Java variables? Maybe you can do a demo on these Java variables, right? So a variable, you know that a variable is just a memory space. It's just a memory space or a memory location. That's what you call a variable, right? So let's look at these variables in Java. Why these variables in Java? So I just need a highlight. Maybe this one will work. Let me just use the yellow one. So a variable is a container, right, which holds the value where the Java program is executing, right? So a variable is assigned with what we call a data type so that we know the type of the data that we're going to store at that area. So a variable is a name of memory location, just like that is a name of memory location. Let's look at this area, which is reserved. We can take it as a variable. Why? Because it's a memory location which contains some value, and then this value maybe can be used by our Java program during execution, right? So that's what we call a variable in general. So maybe now we want to look at specifically at Java variables, but otherwise a variable is just a named memory location, just a named memory location, which is going to be reserved for our program so that it can use during execution. So there are types of variables in Java. There is what we call the local, the instance, and the static. You need to know about these three special types or variables in Java. There are those ones that we call local. Why are they local? There are those that we call instance. Why instance? And then there are those that we call static. You need to understand that. So let's look at what we call local variables. So a variable declared inside the body of the method. There's what we call a method, guys. Don't worry, we're going to talk about it. Anyway, think of a method as a function. You have write a code with a function before. So those functions are the one that we are now calling methods. It's just a terminology which is changing, right? But those functions that you've write in C++, that you've wrote in C++, in C programming, are exactly like those things which are now being called method, right? If you look at this one, it's just a function, like the function that you've wrote in C and in C++. But I can tell you that this is a Java method, right? So I think it's now just the terminology. So a local variable is a variable declared inside the body of the method, inside the body of the method. So those are the ones that you call local variable. Why local? You can use these variables only within that method, and the other methods in the class are not even aware that the variable exists. So a local variable cannot be defined with, you cannot define it with the static keyword. We are going to talk about it when you're doing static variables. Why does it not make sense to make a local variable static, right? Even to make it private. Why does it make any sense? We're going to talk about this later. But let me just show you what can you call a local variable. Like if you look at this, all right, if you look at this, I've got this main method or main function, right? I have this what you call the main method. So if I declare a variable here and say int a, maybe I'll give it 10. It means that this one or this variable is a local variable. Why? Because it is only available in this method. If I go out of this function or if I go out of this method, this one will be no longer accessible. So it is only local to this method. If I can have maybe I can say public, don't worry about these things, guys. You learn them as you go. Maybe let me just say print details and then so if I try to print a maybe if I say sys out, there's a shortcut for this. Okay, so if I try to print a, you see that I'm going to get an error here. Why? If I put this cannot be resolved to a variable. Why? Because this a is only available within this method. I cannot use it outside that method. That's why you call it a local variable. It is only available in this method. or in the local scope. If you go out of that method, you will be not able to access it. Otherwise, I'm supposed to declare another variable here. And it's possible, and I can put 20 here. It's possible. Why? Because this A and this A, they are totally two different variables. Why? Because this one is only for this method and this one is only for this method. So this is what you call a local variable. This is what you call a local variable. So I can say local variable. I can say local variable just like that. All right. Then let's look at what we call instance variable. Let's look at what we call instance variables. Let's look at what we call instance variable. Okay, so there's what we call instance variables. So instance variables, these are variables. What can I say? These are variables which are declared outside the body of the method, but inside the class, right? So if you just declare a variable inside the class, but outside of any method or outside of any function, those variables are instance specific or are called instance variables. We are going to talk about objects. We are going to talk about classes. Maybe that's where you can understand the concept of instances, right? When you say it is called an instance variable because its value is instance specific, maybe that's where you are going to understand what are we saying when I say it is instance specific. And also you need to know that it is not shared among instances. So what are these instances? These instances are just objects of a class. Let's talk about maybe a class of a student, right? Then the object will be you as a student, right? So if you have got your name, it's just your name. You're not going to share your name with someone else. If you've got your pin, right? The student pin, it's just yours. You're not going to share with anyone. So we are saying these types of variables, they're not going to be shared among the objects or among the instances of a class, just like that. All right. So these are what you call the instance variables, those which are within the class but outside of any method. So before looking at the static variables, maybe I can just demonstrate on this instance variable. If I come here, this is just inside the class, but outside of any method. I can have maybe a string, maybe name. Let me just have it without anything, right? So I've declared this variable here, and then this variable will be an instance variable. Why? Because it is instance specific. If I come here inside this one, I can have maybe let me just have an object of this class, which is demo D1, maybe. So because you don't worry about all these things, I'll explain later. Maybe I can have demo D2. These are just objects that I'm creating. Can create objects using the new keyword, and then maybe demo again. Then from here, so it's like if this was a class of students, I can have a student D1 and then student D2. So from here, I can say D1 dot name, right? So I can give this one specifically his name. If he is a student, maybe this one was just demo, but I'm just kind of relating to that. Maybe I can have D2 dot name. Maybe I can give Tawanda there, just like that. So if you look at it, this variable is just one variable, but I'm using it on two different objects or on two different instances. That's why you call it is instance specific. So if I take the name of D1, it is going to give this one. If I take the name of D2, it is going to give me this one. But we are just using one variable. We're just using one variable. So that's why they are called instance specific. And here I can even print it here. Maybe I've said hello Java, and then I can put here D1 dot name, right? Just D1 dot name.
So it will be hello Java, and then it will write Ezekiel, just like that. So if you look at it, if I put d2.name, I'm going to get something different, but we are just using one single variable. We are just using one single variable here. So if you look at it, we are saying this is not going to be, that's why you see this statement which says that it is called an instance variable because it is its value is instance specific and is not shared among instances. If it was going to be shared, when I put this one into name, it was going to override this one, and then even if I say D1, then D2 here, I was just going to have Tawanda on. But this one is not shared. So that's why we say that it is instance specific. So it is an instance variable. So those are the ones which are called instance variable. So it's not mandatory just to put them here. You can also put them maybe just after this main method anyway, which is just not inside the method, the body method, the body of a method. But it is advisable to put them here for the sake of presentation, right? The presentation of your work. So remember, if you want to declare any instance variable, put them here at the top. As soon as you open this block for your class, put them there, right? So that's all on instance variable. Then let's talk about what we call static variables in Java. So a variable that is declared as a static is called a static variable. If you mark it static, it means it's now static variable. So it cannot be local. You can create a single copy of the static variable and share it among all the instances of the class. I'm going to show you what does this mean. If you see on the instance variables, we have said that they are not being shared, right, among the instances. But once if you make it static, it means it is going to be shared. If you are going to have 5 students of that class, if you mark their pin number, if you mark the instance variable static, right, it means that if the variable has pin number, they will be all sharing the same pin number. Because you have marked it static, it means that it now belongs to the class, right? So anyone who is a member of that class can actually enjoy that. So they'll be sharing the same value. So memory allocation for static variables happens only once when the class is loaded in the memory. So this one was just an example which shows this one. If you mark it a static variable like this one, static in the count 2, if you change, which means it will be sharing between these two objects, which means this object will be having the same count as same as this one. So those are what you call static variable. This was just an example showing you how to declare variables, and we've done this. So maybe for static variables, guys, it's just as simple as marking it static like this. It means it's now a static variable. If I run this, you are going to get it, Tawanda. Why? Because the last name I've put here is only what? Tawanda, right? If I change this one, maybe I want this T1 before I put Ezekiel in this variable name, you are going to see Tawanda. Why? Because I marked it static. It means now it is now being shared among these two what? Among these two students. So the last name that I'm going to put on this variable is the one which is going to be shared among all the what? Among all the instances. So think about it before you use static variables. Just think about it before you use static variables, just like that. So those are the ones that were called static variables. Think what happens if I remove this. Let's see what happens if I remove this. You see that for D1, the name is going to be Tawanda, but I didn't put the name for D1. I just put the name for what? For D2. But if I try to access for D1, I'm just going to get Tawanda. Why? Because they will be sharing the same memory space for this variable. Why? Because I've marked it static, right? And then, so it means that it will belong to what? To a class, just like that. So I think that's all on variables. I don't know if I've got questions, but that's all on Java variables. So there are a lot of types of variables in Java, right? We've only done int and a string, but you can use double, can use even the float itself. You can use the character. What else? Yes, you can have double. maybe D, just like this. Maybe this one to take those numbers with the commas. Maybe you can have what else? The car for character. You can have what else? You can have float for floating numbers. What else? The string is already there. So there are a lot of variables. I'm sure you can also have Boolean for true or false, Boolean B for true or false values. So there are a lot of variables that you can think of in Java. So declaring them is just like what you have been doing in C programming or in C++. That's why I've said Java is like something that was taken from C++ as well as C programming. So the way you have been declaring them, just the same, the way that you're going to declare them in what? In Java. So what I wanted to introduce is the issue of instance, local, and static variables. That was the main reason of doing all this. That was the main reason of doing all this. So allow me to move on to the next slide if there are no questions or contributions. But it seems like everything, so far everything is good. Let's look at what we call classes and objects in Java. Let's look at classes and objects in Java. There's what we call classes and objects in Java. Let's look at these things. What are these things? We have been seeing classes on my code. You have been seeing objects when I've declared B1, D1 and D2. Those are the things that we are talking about. So let's exactly look at these things. What are these things, right? So let's look at classes and objects in Java. Firstly, we are going to talk about what we call objects in Java. But guys, take note of this. You cannot have an object in Java without having a class. The first thing is to have a class and then you have an object. So let's talk at what let's look at objects. So if we can consider the real world, we can have what we call cars, dogs, humans, etc. as objects, right? And if you look at it, all these objects have got what we call the state and their behavior. Like a car, you can start a car, has the behavior, right? The state, maybe the car is of red color, just like that. So if you look at humans, you do a lot of things, which is the behavior, right? If you look at the state, you know that the complexion is brown. What else can we look at a person? There are a lot of things to look at. So these are the real world objects. And yet we have got what we call objects in Java. So if you look at this, so if you compare the software object and with a real world object, they have what we call very similar characteristics. They've got very similar characteristics. So software objects also have got what we call a state and a behavior. This is what makes Java a very, very competent programming language. Why? Because everything in Java is just like everything that we have in real world. If you look in real world, you've got these objects, and you can also have these objects in Java, just like that. So before looking at classes, I can give you an example here of this object that we have here. This one, demo D1 and demo D2, these are some of the objects of the class what? Of the class demo. That's why you are seeing demo here, demo here, because these are objects of class demo. So let's look at this class that we call class demo, and then I'll come back here as not class demo, but let's just look at what we call class. What is a class? And then we'll look at all these things later, like I'll do an example showing this class and what blah blah. So let's look at classes in Java. So a class in Java is just a blueprint from which all individual objects are created. So a class is a blueprint from which individual objects are created. Remember, I've said that you cannot have an object in Java without having a class. Why? Because this class is the blueprint, is the description of your what? Of your object. So a class is an abstract description of your object. So for you to be able to create an object, you need a class. So here's an example class, dog. This is how you can create a class. This is just an example of a class dog, and then inside it you are going to have the description of a what? Of a dog, right? So that's what we call a class in Java. We can have, in real world, you can have a class of students, right? And then inside that class, we can describe what students do, right? Students can register, we can have a method to register, right? Students can write exam, can have a method for student to write exam, something like that. And then student have got a name. So these are properties now. So this is the state, right? So that's what you're talking about when you're talking about a class. So here are also some examples of objects of this class that we call dog. You can have such kind of dogs, maybe the German Shepherd, whatever, something like that. So this was an example of a class called the dog. If you look at it, it have got some state or some instance variables, and then after that it is going to have some behavior, which are these methods, right? So this is what we call a class. If you look at it, it is the description of an object, or it is the blueprint from where an object is going to be created. You are going to create an object of class dog, right? That object dog is going to have everything that we have in here, which means the description of the object that you are going to create is coming from this class. That's why we call that the class is a description of an object, because whenever you create an object, it is going to have everything in this class. Let's look at maybe, okay, so this is what we call, the class is also contain data definitions. Okay, so these are data definitions, just like this string breed, age, and what. These are data definitions or the properties that we have been talking about. And then after that, you put the methods. And then before constructors, maybe I just need to demonstrate on this. So we are saying, guys, at the top here, put your instance variables there. After that, you put the methods. That's what we are talking about. And then we're going to talk about constructors. Constructors, if you look at this one, it's the one that you call a constructor. Here we are just calling a constructor. So we are going to talk about constructors. I know maybe you've done them in C, in C++. What are these constructors? They're just methods. We're going to talk about them later. But maybe I just want to remove all this. All right. Let me just do this. Okay, so if you look at this, we've got a class called demo, and I've said public class. This is what shows that this is a class, and I've named it demo. This is the name of this class. So if you look at this class, this is where I'm closing it. Inside this class, I've got the data member, which is a string name. After that, I'm going to have a method. So in a class, you're going to find some variables and some methods, right? And all those things are the ones that you're calling the description of your object. If you look at it, I'm going to have a main function or a main method, which is going to be closed here, and then this method also, which is print details. So if you look at it, when you're going to create an object, when you say that this class is just a description of your object, you say this class is just the description of your object. What do we mean? What do we mean? It means that if I'm going to say D1 dot, you are going to see that D1 is going to have the name, right? If I say name, this name, right? Which means D1 have got the name, right? So when I'm saying that because D1 is an object of this class. So we are saying this class is describing D1 or it is describing an object. If I say D1 dot print details, you see that D1 is going to have the method print details, which is this method which is within this class. Also, D1 have got this main method. So that's what it is. That's what it is. When you say that the class is going to describe everything which is going to be in an object. So when you are declaring an object, you know that an object is just an instance of a class. Why are we saying that an object is an instance of a class? Because it is an example of a class. If you create a new object, it means it is going to have everything which is within the class. So it's just like as good as you are creating an example or something that mimic your class. So that's why we say that this one is an instance of a class, or is an example of your class that you have there, or that you have actually put there. So that's what we call an object. In normal, how to declare an object, you declare an object using the new keyword. So you put the name of the class first here, like demo here, and then you put the reference variable name or the name of your object. After that, you put the new keyword, and then you repeat the name of the class which is called or you put the constructor, then you put demo, and then you put this one, and then you close. This is how you can create this is how you can create a new object of a class. This is how you can create a new object of a class. So this is what you call an object and a class, right? In a simple definition. Now let's look at what we call a constructor. Here we're just saying we are calling a constructor, calling a constructor. What is this thing that we call a constructor, and why do we need it? Maybe that's the most important lesson to take. So let's look at constructors in Java. So in Java, a constructor is a block of codes similar to the method, and it is called when an instance of the class is created. So it is a special type of method which is used to initialize the object. So whenever you're creating an object, guys, whenever you're creating an object or instance of a class, this constructor is just a method or is just a function which is going to be called during the creation of that instance or during the creation of that object. So take a constructor as just a simple method which is there waiting to be called whenever you're creating a new object. So if you look at it, when I'm creating a new object, I'm calling this constructor, right? This is what I'm calling. I'm saying a constructor. I'm calling a constructor, which means it is there somewhere. You're not seeing it here, but it is there somewhere. So I'm calling a method called a what? A constructor. Like if you look here, if I say d1 dot print details, it's a method which I've created here, right? So it's just the same as I'm doing a print details. I'm calling this method called what? Called the print details I've done here, right? So that's how you call a method. So I'm also doing the same. I'm just calling this method, putting this, and then I'll terminate. I'm just calling this method. But this method is a constructor. That's what we call a constructor. So in simple terms, a constructor in Java is just a block of code similar to the method, and it is called when an instance of the class is created. It is a special type of method. That's why we are talking about it. Otherwise, we're supposed to talk about this main method, may print details method, but no, we are talking about a constructor. Why? Because it's a special type method which is used to initialize the object. So whenever you're creating the object, you want to give it some default values. You want to give it some values that it is going to use during the execution of the program. Maybe in case you are not going to put some other values, you want the initial values. That's where the constructor come into play. So every time an object is created using the new keyword, at least one constructor is what is called. So whenever you're creating an object, whenever you're creating at least one, which means there is a constructor which is going to be executed. If you're going to create that method that we are saying is constructor, it means Java is going to create one for you. Why? Because it's mandatory kutupa manual one constructor during the creation of during the creation of an object. So what are the rules for creating Java constructor? So there are 3 rules defined for the constructor. The first one, constructor name must be the same as its class name. That's why you see here, when I'm saying that we have got this demo, right, as a constructor. If you look at it, it is just the same as what? As the class name. So a constructor name must be the same as its class name. And then constructor must have no explicit return type. In other words, a constructor cannot return any type, even void, guys. You cannot return a string from a constructor. For example, you can have a method or a function to add 2 numbers and return the total. We are saying a constructor cannot do that, cannot return anything, right? So it's a must. And then a Java constructor cannot be abstract, static, final, or synchronized. We do not want to see all those keywords on your constructor. Don't worry about what is abstract, what is static, what is final, what is synchronized. Don't worry about it now. We are going to do synchronized. We're going to do it when we're doing threads, maybe static. We have talked about it. What is static? If you mark something static, it means it now belongs to class. It is going to be shared about all. It is going to be shared with all the instances. All right. So know that on a constructor. Also know the issue of abstraction on a what? On a constructor. So those are the golden rules for creating your constructor. Then let's look at types of constructors in Java. So there are 2 types of constructors in Java. There's one which is called the default constructor, which is the no argument constructor. a constructor which is going to take anything. It is not going to accept anything. That's what we call a default constructor. And then there's what we call a parameterized constructor. What is this now? The parameterized constructor. It is the constructor which is going to take parameters. So maybe when you're creating your program, you want to put some values in your variables, you need the parameterized constructor, just like that. So let's look at what you call the default constructor or the no argument constructor. Guys, a constructor is called the default constructor when it doesn't have any parameter, right? What you call any parameter, what you call a parameter, those are the values that you pass to a function or a value that you pass to a method. So if you create a constructor which is without an argument, and then we call it a no argument constructor or a default constructor. For example, of a default constructor, what is the purpose of a default constructor? The default constructor is used to provide the default values to the object, like 0, now, etc, depending on the type. So this was an example of a default constructor here. All right, maybe I can go to this code and then, so guys, the trick here, I've called a constructor that I didn't create. Why? Because Java will always create you a constructor if you didn't create your own. So here I didn't create my own constructor. It means that Java have created the constructor for me, but this constructor is a default constructor that Java actually created for me. So if I came here and say demo, remember this is just the name of a class, right? And then I'm going to use to create a method. And then this is how you can create a method, guys. Remember, a method is just like a function. So let's just keep it cool. Let's just keep it simple, just like this. If you look at it, this is the default constructor that you are talking about. If you look at it, it's not going to return anything here. It means it's a constructor. It must not return anything. Otherwise, we're supposed to write a return statement inside there. But for constructors, there's no such a thing. And then here it is not taking anything. So this is a default constructor. If I'm going to run it, this it's just going to give me 20, why 20? Okay, because I've put okay, I've called the print details method and what blah blah blah. But anyway, nothing's going to change to this code because this default constructor is doing nothing. It's just there, maybe putting the default values. So if I didn't put this constructor, Java is going to create something like this for me and then initialize these variables maybe with the default values, like now. If it is an integer, put 0 there and what, blah, blah, blah. So that's how you declare, or that's how you create a default constructor, and then you can call it here when you're. So sometimes I can use it to actually put the values inside my what? Inside my, maybe I can say this name, what else? This dot name. Why can't I do this? Okay, I can do this, yeah. I can definitely do this. Okay, let me just put Ezekiel there. So what I'm going to do is, look at this, guys. What I've done is very, very simple. Let me take out this one as well. Okay. Okay, look at this, guys. I've created this default constructor. And inside this, I've put the name here. I've set the default value to Ezekiel, right? So whenever I'm going to create a new object of this class, every name of that object will be Ezekiel. Why? Because the default constructor that I'm calling here, this one, this default constructor that I'm calling here is this one. So it is going to assign the name to Ezekiel. Don't worry about this keyword. I'm going to talk about it because I've introduced it. I know it will bring some confusion there. And maybe it was part of your assignment or what. We've been seeing it somewhere. But we are going to talk about this keyword. So if you run this, says hello Java, then it says Ezekiel. Why? Because it have printed d1.name. And if you look at d1.name, where is d1 getting this name? The name is being coming from this constructor. This is where I've actually initialized this what this name for d1. Right? Just like that, I can even remove this static, and then you could get the same output So when I've created D1, it is going to be given the name Ezekiel. If also I put D2 here, we are going to get the same value, because whenever I'm running this default constructor, we are going to get this value. Okay, guys, this is the default constructor. And then for this keyword that I've said, I'm going to talk about it. Guys, this keyword is just a keyword in Java, which is used to reference the object, which is just executing that method, right? So if you look at this, I've created object D1. So this name will be given to the name in D1, right? When I'm creating this one. And when I'm creating when I'm creating D2, sorry, when I'm creating D2, then this name is going to be given to this object D2. That's why we've seen that when I'm testing with the D1, I'm going to get Ezekiel. When I'm testing with the D2, I'm going to get Ezekiel. So that's this keyword. That's this keyword. Okay, so let's look at what we call the parameterized constructor, which has a specific number of parameters and is called a parameterized constructor. So why use the parameterized constructor? The parameterized constructor is used to provide different values to distinct objects. However, you cannot provide the same values also. So guys, if you look at it, this one, this is the default constructor. But what if I want to set the name differently for any object that I'm going to create? What am I supposed to do? It means I need some parameter here. Maybe something like, let me just say string n, because I do not want to cause some confusion there. I do not want to solve some confusion there. So what it means is that whenever I call, so you are seeing here that I'm going to have that this constructor is undefined. Why? Because I no longer have the default constructor. So I have the constructor. So Java is now expecting me to use the constructor that I already have here, right? And what is this constructor do? Yeah, this is a parameterized constructor because it is taking a parameter here, right? And then if you look at it, if I pass a value here, which is a string type, and then it is going to be passed to this name. All right, so I want to say D1. I want you to give a name called Tawanda, right? So it's as good as I'm calling this method here or this function, and I'm passing Tawanda, which means Tawanda is going to come here in N and then passed here, which means it will end up there, but specifically for that object, right? And then I want to say D2, you are Ezekiel. Right? So if I print this, I'm going to get Ezekiel. Why? Because I'm printing D2, name for D2. But if I decide, what if I decide to print for D1? What am I going to get? I'm going to get Tawanda. Now you are seeing the difference. I'm now choosing the name of every object that I'm creating. I'm not choosing the name of object I'm creating. So I want D1 to be what? To be named Tawanda, and then this one to be named Ezekiel, just like that. So how this magic actually happens is that you are calling the constructor. You are saying new and then calling a constructor. And then this constructor is responsible to set this name to what? To Tawanda. And then this one is also responsible to set this name to Ezekiel. But take note of this, guys. D1, we have got its separate memory for this name. And then D2, we have got its separate memory for this name. That's why we are seeing that we are not going to wrap this initial value and put this one. Unless if you mark it static, that's where you are going to have that effect. So remember that D1 is going to keep its separate memory for the contents of this class, and then D2 is also going to keep its separate memory for that. So that's it for parameterized constructor. So guys, you are not obliged to just put one parameter. You can put as many as you want. You can put as many as you want, as much as you have the instance variables here. If you have got the 30 instance variable, you can even put also 30 parameters here. No problem, right? Just like that. So the confusion that I was avoiding here is of giving this variable the same name as the instance variable that you want to give here, that you want to put the value there. Guys, this name is this name, right? But it's different from this variable. This is the instance variable. This is the local variable. So normally you can also use this keyword to distinguish between the local variable and the instance variable. That's what I was trying to say. If you print it, the effect will just be the same. This one is being treated as the local variable, and then this one is being treated as the instance variable. So why this one being treated as the instance variable? Because you have used this keyword. So this keyword will be referencing to the object, right? So the object have got this variable, this instance variable, not this one. This one it's a local variable is for that method. So if I remove this, you see that this one will be referring to the local variable. And if I run this, I'm going to have a null because this one will be not that one. So remember to use this keyword. Remember to use this keyword whenever you have the local variable which have got the same name as the one of the instance variable. That's what I wanted to tell you about this keyword. So that's all on this keyword. So on the difference between a constructor and a method. So guys, we've said there's a method in Java and then there's a constructor. At the same time, we've said that the constructor is also a method. So what are the difference between a constructor and a method? A constructor here, if you look at it, a constructor is used to initialize the state of an object, where a method is used to expose the behavior of an object. A constructor must not have a return type. As you have seen here, guys, there is no return type. Also, a method must have a return type. So for a method, if you look at it, this one it's void, that's the return type. And if you look at this one, it's also void. You can have a string method, you can have an int method, just like that. So the constructor is invoked implicitly. What it means is that whenever you are creating a new object, you invoke the constructor implicitly. You do not need to call the constructor directly. So it's implicit, it happens implicitly. But for a method, it's explicit. That's why you see here that I have to call the method D1 using the object D1.print details. I have to call the method this way. That's explicitly calling a method. So we are saying the method is invoked explicitly. So the Java compiler provides a default constructor if you don't have any constructor in a class. Like before, when we were not having a constructor, the Java could actually give you a default constructor. But the method is not provided by the compiler in any case. If you do not declare your method that you want to use, do not look forward to be given your method by the compiler. There is no such a magic. But for a constructor, there's a magic. It will give you a default constructor. So also the constructor name must be the same as the class name. But the method name may or may not be same as the class name. So here, if you look at it, the constructor is just the same name as the class. But for a method, this is main method. This is print details method. It's not a must that they must be the same. So that's all on constructors. I don't know if I've got questions for this one too. I have questions, contributions on methods, on classes, on constructors. Seems like everything is well. Don't worry, I will ask you if you are not going to ask. I'll ask you if you are not going to ask. So let's look at maybe access modifiers. There's what you call access modifiers in Java. This is the important, very, very important part of Java, or part of this presentation. Why guys are going to do inheritance? You need to know access modifiers. You're going to do inheritance, you need to know access modifiers. Why? Because there are some of things that you can inherit and some that you cannot. So the determination is on access modifiers. So yeah, you need to understand access modifiers. You need to understand access modifiers. Okay, guys. Let's look at these things that you call access modifiers. What are these animals? What are these things? All right, what are these things called access modifiers? So what are access modifiers? Access modifiers are keywords that can be used to control the visibility of fields, methods, and the constructors in a class. So to control the visibility, what is going to be visible? What is going to be visible to other classes, right? You can do that. You can control that using access modifiers. So the 4 access modifiers in Java are public, protected, default, private. For now, you've been seeing me using public keyword. That one is an access modifier. The default one, you've been seeing me using it, but some of you might not know that here I'm using the default access modifier because it's not a written default, something like that. And then private, I didn't use it. Then protected, I didn't use it. So Java has 2 types of modifiers, the access modifiers and the non-access modifiers. Don't worry, I'm not going to talk about non-access modifiers for now, but when you're doing abstraction, I'm going to talk about abstract classes. So abstract is now in non-access modifier. But for today, we're just going to talk about the access modifiers, which is the public, protected, default, and private. How is it going to affect the visibility of fields, of methods, and the constructors in a class? Just like that. That's all about this presentation. So let's look at 4 types of access modifiers. The private one. So the access level of a private modifier is only within the class. It cannot be accessed from outside the class. So guys, if you mark something private, we can only access it within that class, right? It's just like your secrets. If you do not tell me, I might not know that. It's only yours, right? If you tell me it's now public, it will be now what? It will be now public. So if you mark it private, it means that the access level of a private modifier is only within the class and it cannot be accessed from outside the class. What if you mark it default? So the access level of a default modifier is only within the package. Guys, when you're talking about the package in Java, you're talking about a folder, right? So your project, they've got what you call a folder. So the default access level, the default access modifier is only at or within the package level. So if you have got the classes which are within the same folder, or if you have got some files which are within the same folder, this class which are within the same folder, it means that we can access that from one file to another. And once if these files are within the same folder, so it cannot be accessed from outside the package. This is the folder that we're talking about. So if you do not specify any access level, it will be the default. So in other words, if you not mark it public, if you not mark it private, if you not mark it protected, then it is what? It is protected. I think you've seen it when I have declared this variable string just like this. It means you have got a default access modifier. Why? Because I didn't mark it private and I didn't mark it public. I didn't mark it protected. So it's the default access level, which is within the same package or within the same folder. And then there's what we call the protected. So the access level of a protected modifier is within the package and outside the package through child class. So guys, take note of this. For protected, it's only within the same folder, but it can be also done outside the folder through what we call inheritance or through the child class. So if you do not make the child class, it cannot be accessed from outside the package. So for this one, I'm trying to demonstrate it, but we are not going to do inheritance. So maybe I'll just keep it cool. I will not introduce the concept. I'll just put it and then you see what will happen. The magic will be happening there. And then we are going to learn inheritance later. Maybe tomorrow, if I managed, can have another tutorial, then you can do the object-oriented programming part. So there's this, the public keyword, which is the public access modifier, which is the access level of a public modifier, which means is everywhere. The access level of a public modifier is everywhere, whether within the same package, outside the package. So it can be accessed from within the class, outside the class, within the package, outside the package. So when you mark it public, think of that. Think of that. Am I not exposing things which are supposed to be only within this class? Okay, so understanding the Java access modifier, this is just like guys, the how do you call it, the summary. If you mark it private, it's obvious that if you are within the same class, you can access it. Or if you are within the same package, no, and no outside the package by subclass only, which is 3 inheritance, no, and also you cannot access it outside the package. We are going to demonstrate this. And then if you are within, if you mark it default, if it is the default access modifier, you can access it within the same class, also within the same package. But if you try to do it through inheritance, no, and also no through outside package, if you try to access it outside the package. To say you have got a class in another package, in another class, in another package, and to try to access the members of that class, they are not going to see each other. And then if you have got protected, if you mark it protected, you can access it within the same class, within the same package, and outside the package, but through inheritance. But try to access it only outside the package, you cannot do that. But if you mark it protected, it's yes for everything. And so take note of that before you mark anything public. Take note of that you still need to avoid, the issue of sensitive data. You need to make sure that you know that. So let's try to look at this. What can I do is, guys, to make it simple and cool. All right, let me do this. I am going to have another class here. So if I put another class here, just down there, I can have 2, 3, 5 classes, 20 classes at the same Java file, guys. It's permissible. If you look at it, this is the first class, right? This is the first class from here, public class demo. So I can have another class here. Let me just mark it test. Sorry, I need to say class. Guys, andivumi ukuthi public class here. Why? Because you can only have one public class at a single Java file. You cannot have more than one public class. So these other class can be private, maybe protected or whatever, but they cannot be public. Why? Because the one which is public is the one which is considered to be the main class on that Java file. It is one which is considered to have the main method. So take note of that. Take note of that. If you're going to do that, you're going to mess around with your code. So I can mark it test, class test, what else? This is how you can create a class in Java, just as simple as this. Then I'm going to put something here. I'm going to put something private, and then maybe I'm just going to say private int, let me just say in the edge, then I'll put 20. All right. So I'm going to test the concept of private. Guys, here they are saying if it is within the same class, right, you can access something which is marked private. But if you try to access it, you are within the same package, right? Just like in my case, you are within the same package. Try to access it. What happens? All right. So here, for me to be able to access this variable, I need an object of this class test. You need to take a note of that. I cannot use this without using this class test. So how can I do that? Guys, allow me to remove a lot of junk. Allow me to remove a lot of junk. Allow me to remove all these things. All right. So that I can make my code as clean as possible, as small as possible. Maybe allow me to remove all these things. We've done constructors. And then what else can I have? All right, let me just leave the name string there, string name there. Okay, so if I want to try to use this edge here, what I'll do is I'll create an object of test. I will say test t1 is equals to new test, all right? Boom, just like this, I'm done. So now I want to print, let me just say this out. All right, then I will say t1 dot, because remember, t1 is an object of class T, of class test, so it must have edge, right? but boom, I'm going to have an error. It must have this test because this object is of this class. And remember, I said that if you create an object of a class, it's an instance of that. So it is going to have everything in that class. But boom, this one is not there. Why? Because it's saying that the field test.h is not visible. Why is it not visible? Because of the access modifier. We have marked it private. And if you look at it, we are not within the same class, right? We are in a class demo and you are trying to access it here. Then you are going to have trouble. Why? Because we have said if we are within the same package, yes, but you are not within the same class, you are not going to be able to access something marked private, right? But if I try to change it here and give it the default access modifier, I'll put nothing there. You could see that I can use this edge, just like that. So you need to understand these access modifiers, and I can print this 20 here, which is this 20, just like that. So if you mark it private, guys, know that it is only available in that class. It is only available in that class. Otherwise, outside that class, you cannot use it. So I can go on to demonstrate here. I've demonstrated that we are within the same package, but it's not possible. I can go on to demonstrate outside the package. Let me just do this. All right. Let me remove this. Don't want to see some errors. Okay. This is my project, guys. This is my project. And if you look at it, I've got this demo package. This is where I am here, package. So I'm going to create another package. This is the default package. I do not want to use it. I'm going to create another package. Okay, to make it easier, okay, let me just create another package. Okay, let me mark it what? All right, let me mark it test. Normally I need to put the small letter for package. Yeah. These are naming conventions. We're going to talk about them later, but these are naming conventions. Okay, so I have another package. Okay, I have another package called demo. So in this package, I'm going to put another class. Remember, I want to try to test all these ones. I'm trying to test all these ones that so we've got some class demo here, which is within this package, and within this class, we have also another class. So we've got this class which are within same package. We've got two classes here within the same package. So here, let me just create another class. So I say new class, and then this class, I'm going to mark it what? So guys, in this class, I'm not going to put, just wait a little bit. I'm just going to put, just wait a little bit.
Hello, Monica.
Drew Boyer.
Bozvo kuri zviri kubatika here apa.
Iwe siyana neni.
Zvinoita.
Ndikutemba newe.
Zvinoita, usambotyi. Zvinoita bo.
Repeat.
Alright, iri bo.
Yeah.
Vanoona pane chiti vanoda kuvhunza vanoda kudiwa vanozokoda kuzongotaura nyaya dzavo mhene vanoita sei. But anyway, ndatoona kuti pano vanhu vari active, at least pano vanhu vari active. Andrew, zviri sei?
Tiri bo sei, muri sei sei?
Moshe ndanzwa Monica kuti ari kutemba newe. I hope uri kubata nditi.
Mheno sei, zviri kuita.
All right, it's okay. So guys, let's look at this one. I was creating a class, a class in this package. If you look at it, the package is test, and then I'm going to create a class. Let me name it what? Let me just name it demo 2. Let me just name it demo 2. You can give it any name that you want. Let me say finish. So if you look at it, I've got this demo and then this one. But if you look at this side, they're in different packages. This one is in test package and this one is in demo package, right? So what I'm going to do again, I'm going to have an int variable. Let me just make it private int, and then me say demo2, and then I'm going to put a 30 there, just like this. Okay. So I'm going to come here, and then what I'm going to do is I'm going to try and have the object of class demo2, and then I'll create this one. I'll say d1 is equal. This is the object of the class demo2, right? Yes, just like this. Oh, I'm going to have an error. Why? Because I'm trying to use a class which is from another, from another package. So I need to import that class. You need to understand that. You need to import that class first for you to be able to use it within that class, within this class. So after doing this, since I've imported it, I have it here, so I can use this class. And in here, I've got this variable called demo2, and I've got an object of this class. So since I have the object of this class, I can also use this. So let me try it. That if I'm here, can I use this? So I can say d1.demo2. Oh, I cannot use it. What's the issue here? It's what? Okay. Say demo2 is not feasible. Now the issue of what? Of visibility. It's now the issue of visibility. Demo2 is not visible, but here I want to say sys out. All right. All right, so let me do this. All right. So D2, I cannot use D2 here. Why? Because the visibility. And I've been given a suggestion. Change the visibility of demo2 to public for you to be able to use it here. Are you seeing it? So I cannot use this one because it's private. So if you look at it, we can come back here and see that we cannot use it if it is private. You can try it even through inheritance. I'm not going to talk about inheritance. So this column, we're going to ignore it. But guys, for private, trust me, you'll be not able to use it. So if you mark something private, take note of that. It is only to be available within that class. Okay. Since I want to run this program, I'm going to remove this to remove some errors, and I'm going to mark it public as it was being suggested so that this error will be gone, which means I can use demo2. So if I run this, I'm going to get 2030, this from Edge and this from demo2. All right, we are good to go with this private. Then let's look at the at default. So if something have got default access modifier, it means you didn't put anything. It's just like this that we have here, which is a string. All right. So for within the same class, we are not going to test it. For within the same class, it's like we are saying this class demo, and then we've got this string name. We can always use that. We have seen that before. Then let's look at when you are within the same package, like here, guys, this class test is within the same package, and we've got this as a default access modifier because I didn't put private, I didn't put protected, I didn't put public. So if you look at it, I can use it. If you look at it, I can use it here. Here. So it means that's why we have got a yes here because we're within the same package, within the same folder. Then let's look at this side when you are outside the package. Okay, guys, if I come here in mark it default, if I remove this and mark it default, you see that when I do this and I have an error here, if I come here, the error is here, which says that the demo2 is not visible. This one is not visible. Why? Because I've marked it default. So if it is default, you cannot access it. Just need to know that you cannot access it. That's why here we have a no here. So that's it. What if I mark it protected? Let's see if I mark it protected. So if I mark this one protected, if I say protected, let's see what is going to happen. We have marked edge protected. Is it accessible? Yes, it's accessible. So why we are saying if you are within the same package, yes, we can access it. What if this one is only 3 inheritance? We can access 3 inheritance, but we are not going to do inheritance, guys. Let me just skip that. And then outside the package, you cannot access it. So if I come here and mark this one protected, it's obvious that you cannot access it. That's why I've got an error here that this one, this demo2 is not feasible. So to only access it through public. So I can go for public here. If you say public, it's yes everywhere. So if I mark this one public, if I mark this one public, it means you can access it. Here you can access it. What if I come here and mark this one public as well? What will happen? It means that you can also access it here. You can also access it here. You see, you can access this one here. So if you mark it public, it's to know that Apana secret and it's visible to any class that will be within that project. You can just import that class and then you can just import that class with the variable and then you can use it. You can access it if you create an object of that class. Okay. So that's all on access modifiers. I don't know if I've got some questions, some contributions. Okay, people do not want to ask, do not want to contribute. Oh, people do not want to ask and do not want to contribute, but anyway, you can always come back to this recording and you can listen to it. Now let's look at the Java operators. Do we have something new on operators? I don't think we have something new. Let me just go through it, but you know these operators, guys. You have been using this. You have been adding, you have been subtracting, you have been dividing, you have been finding the modulars. We've been doing this in C programming in C++. There isn't anything new in Java. There isn't anything new in Java. So maybe instead of skipping it, I'll just have maybe 5 minutes talking about this. So Java operators are used to perform operations in Java, variables as well as values. So if you look at this, guys, can have this operator here. Maybe you can have this operator as well, which is an addition operator. So Java divides the operators into the following groups, which is the arithmetic operator, the assignment operators, excuse me, comparison operators, logical operators, bitwise operators, just like that. So arithmetic operators are used to perform common mathematic operations like bit addition, bit subtraction, bit multiplication, and then bit division, or maybe bit to find the modulus, or even the increment and decrement operators. So these things they've been around for a while. We have been using them for C programming. We have been using them for C++, just like that. So I don't think it's something new. These things have been around. I don't think I can waste much of your time looking at this. Unless if there's someone who's saying I cannot create a program to add 2 numbers. I cannot create a program to add 3 numbers. Maybe to add 3 variables, whatever, to subtract, to multiply, or to find a remainder. Yeah, then I'm supposed to do that. So there's what we call an assignment operator. This operator have been around for long. This is not an equal sign in the programming, but this is an assignment operator. So you need to take note of that as well. So a list of all assignment operators, you can have a shorthand of assignment operator, something like this, where you can have maybe the best way is to demonstrate for this one. Maybe I can quickly do this. Okay, allow me to take out all this junk. All right, this is just the main method. When I can have int a, right? Maybe put a 0 there. Then I can have int, not int, but I can have a plus, then I will assign maybe here. What it means is that this is as good as a is equal to a plus 10. So it's a shorthand of writing A is equals to A plus 10, right? So it's the same for multiplication, it's the same for what? So this is just a shorthand. So it's an assignment operator. You are adding a 10 to A, and then you later assign to A. That's why we say it's an assignment operator, just like that. And then the comparison operators, the greater than, the less than, greater than or equal to, less than or equal to, not equal to, all those are the comparison operators, these ones. You have been working on these ones. When we are using the if statements, something like that, that's where you use these ones. If you want to compare, if two things are equal, you need to take note of these guys. If you are comparing strings, because the strings are objects in Java, you are not going to use that double equal sign, right? Maybe I'll have a chance to show you, but maybe this is the right time to show you. Yeah, because I don't think I will remember that. If I put this one equal to, maybe, let me just put Ezekiel just like this. Oh, all right. And then if I'm trying to see if this name is equal to something else, how can I do this? I can use an if statement. Guys, this one is not new. The if statement that we've been writing in C programming in C++, it's just the same as the if statement in Java, simple. So to those who have been developing some programs or who have been learned C, C++, C#, what, the if statement is just the same. So I can say, so I cannot say if name is equal to name like this. I cannot say this one in Java. Why? Because this comparison operator is only for primitive variables. It's not for objects. I cannot compare objects, right? So how can I do this if I want to compare these two things, right? How can I do this if I want, okay, no, here I can put something like this, all right. So I cannot compare these two things, right? If this is string, which is a name and is equal to this, I cannot compare these two things. Why? Because these are objects. A string in Java, a string is a class, right? So whenever you declare a variable of type string, it will become an object. That's why I'm saying that. It's as good if I created an object demo, right? So here I can say name. So in a string class, there's a method, or I cannot reference to that without an object. Holy shit. Let me just take this one inside this main method. I'm sure I can use this name now, right? Yes. Okay. So let me say, so in a class, in the class string class, there are methods which are there. There are a lot of methods. Go in to do the string class. You can compare, you can check if they're equal, you can do string concatenation, you can have a substring. There are a lot of string methods. I'm not going to talk about it. What I'm going to talk about is the equals and equals ignore case. So if you want to compare the objects, you use the equals like this, equals, then so I'll put here maybe something like let me try this. I want to check if Ezekiel is equal to Ezekiel. Then if so, I want to print out this out. Supposed to do this shortcut here that I can use. Right. I want to print out that they are equal, just like that. So if I run this, I'm not going to get anything. Why? Because I do not have an else. Let me just put an else. I'm not trying to make it complex, guys. But this one, I'm sure is something that you understand, right? This out. And then I'm going to say not equal. This is basic, very, very basic. Very, very basic. So you see that it is not equal. Why is it not equal? Because this I've put a small letter here. So it needs to be exactly. If you are putting equals, it needs to be exactly, even in terms of what? So it will tell me that these two strings, they are equal. So the string in name is said to be equal to this string that I've put here. So what if you want to ignore the case? Like if I put the small letter here, it must tell me that this is equal instead of saying this is not equal. So you need to use equals ignore case. There's equals ignore case. If I just say this, equals ignore case, something like this, equals ignore case. If I use this, it will ignore the case. And if I run this, it will say that it is equal. So this is how you can compare. So this is the comparison among objects. This is an object and this is also an object. So you are comparing two objects. So you can use the equals and the equals ignore case. Okay. I think I'm done on this. What else? Java logical operators. These are also for you to test for true or false values with logical operators. So this is the end. Sorry. This is the end or and the not logical. So you can use these ones. Maybe if I want to check for two things, maybe I can put an OR here and then I'll put another expression there, or I can put an AND there, and then something like that. I've been using it. You've been using all these things. So I think that's all on not I think, but that's all on Java operators. I don't know if I've got some questions. Someone want to ask? Someone want to contribute? Think everything is well. I think everything is well. People do not want to ask. It seems like everything's okay. Okay. But there's a hand by you bet. You bet. You can unmute yourself and you can contribute or you can ask.
Okay, how are you, sir?
I'm good indeed.
I'm good. I wanted to ask, you're only mentioning arithmetic operators and all those operators. Can we not also use the conditional operators here in Java, or we're only sticking to those operators that that you stated?
Conditional
Like for
operator.
example,
Yes.
yes. Like for example, we've got the general operator under the conditional operators.
You can use
Can we
them.
not? Okay.
Yes, you can use them. It's only that I've ignored that because I know you are not, those are the things that you can mostly not use when you are doing the kind of questions that you that we ask you. So I'm trying to avoid such of things that requires much thinking. But you can use them as well. You can use those ternary operators. But to make it simple, you can just leave it cool, like those operations, they can do anything that you want.
Oh, all right. Thank you, sir.
Yes. Gerald, do you want to say something? You can unmute yourself.
Okay, yeah, thank you. I want to ask, how about bitwise operators? I don't know how to use those bitwise operators.
You can use them as well in Java. It's only that I'm ignoring those things. That's why if you look at on my slide, I've ignoring those things. Why? Because it's, if you look at it here, okay, let's see. We have them here. But if you look on my slide, I'm sure I didn't put them. Why? Because those things, normally you are going an extra mile on a Java program. You are going an extra mile, and those are things that you, for this module, I don't think those are things that you are going to use for this module, but you can always use them. You can always use them. You can learn about them, but I'm trying to compress and put those things, or put the introduction, so that you can explore more. Feel free to explore more on Bitwise. That's why I've put them there. Few more to explore on anything that you think can help you to write your code neatly, maybe to simplify it, though it will be a little bit complex, but it will be simple because it will be a very small program. So that's what I can say on those things. So feel free, Gerald, to go and look on Bitwise operations. How can you use them? And if you saw a question from the questions in the assignments where you can apply it, you can even apply it. But what I know, there are some of things which are simple, like what we have done, which is enough for every that you need. I hope you are answered.
Okay, thank you, sir.
Okay, so maybe what I can do is just want to lower your hand, okay, so that I know, yeah. So maybe what we can look at now is what? Let's look at Java flow control. But these things, they're just the same, like what you've done in C and C++. But you know, there's some people, you know, who didn't even look at this even up to now. So yeah, let's just go through the Java flow control. We've got the if, the switch, the while, and the for loop, all those things. Those are things that we are talking about when we're talking about the Java flow control. You want to control the flow of your program. So let's look at this. Let's look at this. We are going to quickly look at this. So guys, allow me to skip some of things that I think you know. But if you see that that area, it's a gray area for you, please do not leave me just skipping that area, and because that's the best time for you to get help. So if a statement in Java, let's look at if statement. So if statement in Java. So the Java if statement is used to test the condition. It checks Boolean condition, true or false. There are various types of if statement in Java. There's the if statement, the if else statement, the if else if ladder, then the nested if statement. For the if statement, I've used it before when I was talking about how to compare two objects, right? I've actually used the if statement. Okay, so there is the if else. Also, I've used the if else as well. So maybe the if else if and also the nested if, right? So let's look at the if the Java if statement, which it tests the condition and then it executes the block. It executes the if block if condition is true. So normally this condition that you put here is something that results into Boolean value, which is either true or false, right? So if you look at this, this was an example which was checking the age. If the age is greater than 18, then it says that the age is what? Is greater than 18, just like that, as simple as that. Let's make sure that we are always on mute. Let's make sure that we are always on mute. Otherwise, because I'm on headphones, so any slight noise will distract me. Okay, so so this is the if statement, and then the if else statement. You have seen that you put the condition here. If the condition fails, we execute what is in else statement, just like that. So without overlooking at this, yeah, this is what we're talking about. So guys, let me just remove all these things which looks like complex things. Let me just move all these things. Okay, so maybe I can have something like int age. Maybe let me put 18, right? And then I want to check if age. So guys, if you put, so anything that you put here, guys, it must be result in a true or false, just like that. It must be result in true or false. So if I say if true here, right, what happens? Don't worry about the warnings. You see that it is saying equal. Why? Because this condition that I've put here is true, right? So here you put something that it can give you a Boolean letter that can either give you a true or a false. So if I put a false here, if I say if it false, it's obvious it's false. So it's going to run the else part. Just trying to show what is happening here. What is happening here. So if I say, so the warning was just that I write a code which is not going to, if I put a false here, if I come with the warning is such that this one is a dead code. Why is it a dead code? It's obvious that this code is not going to execute whatsoever because here we've got a false, so it will be always false. So avoid to write dead codes, right? Yeah, that's the warning. So if I say if age is greater than 18, right? I'm going to say over 18. Else I'm going to say under 18, right? Power mpinda nditi under 18 watopinda mpinde kana muri under 18. Okay, so it's under 18. Why? Because saying what? Under 18. Okay, I used greater than, so greater than or equal to 18. So greater than or equal to 18. If I say greater than or equal to 18, it says, yeah, it says you are over 18, right? Otherwise, you are under 18. So that's how you use if else. That's use the if else statement. All right. What else? Let's look at if else if condition. So on the if else if ladder statement, what is happening here is that you have a lot of if statements, and it will be like you compare the first one. If the first one fails, compare the second one. Okay, let me just say here, let me say if less than 18, right? It's supposed to print that you are under 18, right? Let me put what? This one's not. All right, let me just put a 20. I just want to. All right, if you say 18, let me leave in 18. It's just a metaphor. All right, let me put a 70. That's what makes it sense. All right, it says that you are over 18. If less than 17, okay. If less than 17, it says to be you are under what? I've changed this one. All right, yeah. Here, let me put a 20. Yeah, now it makes sense. If it says less than 20, game. It can't be. What I'm supposed to test? Okay, I need the else if statement. The else if. Let me put the else if. Then we argue about that later. Else if statement. I'm going to put another else if statement. Else if statement, and then I have a else here. All right. So what I'm going to do here, guys, it's very simple. For the issue of age, it's not working. It's not working. All right, guys, it's not working. What can I do is let me think of something. Let me think of something. Maybe let me have grade, right? A grade. And then you want to look at grade. Let me just put a 20 there. Yeah. Then I'm going to say if grade. All right. Now it makes sense. If grade is less than or equal to maybe 15, and then I'll say your grade is E. Maybe something like that. Let me just say you something like that. Then I'll say else if the grade is greater than, maybe it's greater than 15. If something is greater than 15, but let me put an int grade, is less than or equal to, let me say 30. Then let me just put that, allow me to copy and paste. Programmers, they Control-C and Control-V a lot. So allow me to do that. Let me just say the grade is E, So let me put also, allow me again to copy this and paste. We are programmers. We are allowed to do so. Even you're allowed to do so. Okay, so this is supposed to be correct. But know what you are copying. So I'm going to say if this one is greater than 30, but maybe less than or equal to 45. All right. Then I'll say that the grade is now D, and I'm going to leave it here. I'm going to say the grade is what? Is D. All right. So I'm just going to assume that else passed. Right. Let me just assume that. So if you look at this, what is going to happen here? I've put 20. Let me run this to say the grade is E. Why the grade is E? When I put 20, why the grade is E? Let me see here. Okay, we are saying if, well, we said if grade is less than 15, it's U. But it didn't print U. Why? Because here with 20, so if 20 is less than or equal to, then it says no. Then it goes to the next else if. It will check the condition. Then it will see that the grade is between 15 and 20, 15 and 30. That's why I say that the grade is E. What if I'm going to put 50 here? What is going to happen? It's going to say passed. Oh, great. I hope everyone is going to get a pass on this module. Yeah. So what is going to happen here, guys, that is going to test here, then it's false. So it goes to this next else if test here, it's false. Then Then it comes here, is it 50 between 30 and 45? No. So it is going to print that you have what? You have passed. Just like, so that's how the else if works. So it's just going to test the if. If fails, then it goes to the next else if. If it fails, to the next else if. It fails, the next else if. It fails, then it look for the else part. Just like that. So that's how you can use the if, else, if part. And if you look at it, you have got a pass, and I hope everyone is going to get a pass, you know. So this was an example of an else if. It's an example just like the one that we've did. And then the nested if statement is when you're nesting, guys, when you take something, then put inside maybe a block of code, that's nesting. So a nested if, this one is the nested if. You have take the if statement and put it inside an if statement. So it's a nested if statement. You can do that, guys. Maybe let me just take off everything. No, I don't like complex things, you know. Just want to keep things cool. You know, just want to keep things cool. So that Monica can handle it. And who is that? It's Andrea. Andrew can handle it so that he can actually later on teach Monica. So guys, you can have a nested if statement. A nested is when you have another if condition inside here, right? But maybe I can say, I've said if grade is less than or equal to 15, then you can have another nested if statement. Maybe if the grade is less than or equal to 15, and then maybe want to check something else, then it's the condition that you are going to put here, and then you put something inside. So maybe if there was an issue that if the grade is less than or equal to 15, and then you want to test something else before giving the grade, but before giving something, that's where you are going to use the nested if statement. Then you put the nested if here, and then you put the condition, and then you are not bam, done. So that's it on nested statement. What else? This was the nested. If you look at it, okay, so we've got if the age is greater than or equal to 18, and then after that, we're going to have again the if inside this if, which is going to test about the weight. Then it is going to tell you that you're eligible to donate blood, just like that. Okay, that's all about the if statements. Sorry, I don't know if I've got questions here on the if statement. You know, these things are very, very simple. Any contribution? Oh, Colin, want to say something?
Hello, sir. How are you?
I'm good, and you?
I'm fine. Okay, on the if statement, is there a violation if you don't use the else statement? You're just continuously using the if statement.
There is no violation there. You are not forced to put an else statement whenever you put an if, but it's always advisable to put the else because you are testing a condition. You are saying if, which means if that condition fails, you want to do something. So you can have a chain of if statements, but you need to take note of the logic. If you're going to have a chain of if statements, make sure that the if on the second step is not going to work in hand with the if at the top. What am I trying to say is that whenever you want to test the same variable, right, for some specific condition, the best choice is if else, if else, if else, if, and then else. But if you want to test the things which are totally different, you can have a chain of if statement. If this, if this, if this. But it's advisable to say if, then you put the else part, so that we know that the condition failed. That's why we are on this step. So normally that's the purpose of an if statement. But we know that sometimes there are scenarios where people can just use an if statement without not worrying about the else part, because maybe they want to just exit. If you, it's very simple. If I come here and I say if grade is less than, then maybe I can say return, you know. If I say if grade is less than or equal to this one, I can just say return. So there's no need of else there, because I know that if it is just, if it is going to get in here, it is going to what? To exit. If I put here maybe 0, and if I do this, you know, it is just going to, maybe let me try to do this. Sure, it should work, you know. Do not laugh at me. All right, sys out. All right, I need this shortcut, and then I'll say hello. Let me see if I can get this hello. I cannot get this hello. Definitely, I cannot get it. Yes. Oh, super code. I cannot get this hello. Why am I not getting this hello? Yet it was supposed to say after this one, it was supposed to going to run this. It is not going to run because it is going to exit whenever I call this return. So I know that if the condition is going to be false, obvious, it is going to run this next call. So I'm not worried about the else part because I know what I want. And you see that I'm seeing this error. So some of the time it's not necessary to put any else, but most of the cases you need to put the else part. So I think you are well answered here. You are well answered here. Anyway, let me remove anything that is to do with the if statement. I don't know if I've got other questions, contributions. Okay, let's look at the switch statement. This one I'm not going to take a lot of time. Allow me. So what? We already 2 hours. Okay. I think I need a drink now. Water, not a drink. Water. I need water. Okay. Let's look at the switch statement, the Java switch statement. Let's look at the Java switch statement. Okay. So a switch statement in Java, the Java switch statement executes one statement from multiple conditions. So if you've got multiple conditions that you want to test, but you want only exactly one condition to execute, you can choose to work with a switch statement. So there can be one or any number of case values for a switch expression. The case value must be of switch expression. I'm going to talk about this. Type only. So the case value must be literal or constant. Excuse me, it doesn't allow variables. So the case value must be unique. In case of duplicate value, it renders compile time error, going to get an error. So if you cannot have case one, case one, case one, case one. You cannot duplicate, otherwise get an error. Each case statement can have a break statement, which is optional. Yes, it's optional to put a break on each every case statement, but you need to know the consequences. What are the consequences? Then the case value can have a default label, which is optional as well. So this is the example of a switch expression. What else? Boom. So it's very, very simple, nothing else. So this is an example of a switch expression, a switch statement in Java, where you can say switch and then you put an expression. Sorry guys, network is doing its things, I was knocked out. I think we're switching from generator to the grid. I think Cesar was off. Yeah. Okay, it's still recording. Nice. So we're looking at switch statement. I'm audible, right? Am I audible?
Yes, sir. Yes,
Okay,
sir.
okay.
Yes.
Okay, thank you.
Yes, we can hear
Thank you.
you.
Okay, thank you. I hope this one is not going to happen again. We talk about switch statement, right? Okay. So we're saying this one is just an example of a switch statement. And that's how you can write a switch statement. Anyone with an issue with a switch statement? Okay, let's have a switch statement. Just like what we're doing with else if what I can have it here again. So let me have a keyword switch and then this one. And the switch is just like any function, just like a function. And then what you pass here, guys, is a switch expression, which must happen to be a constant. So I can put here grade, right? So any case that I'm going to put must be of type grade. What does it mean, guys? Grade is an integer. So any case that I'm going to put must be of integer type. So I can have case 1, case 2, case what. So I'm not going to use grade here. Otherwise it would be misleading. Let me just say choice. Choice. And then here, let me just put choice. Right. Coding and the spellings. These are two different things. Okay. So I can have maybe case 1. Because choice is an integer, maybe you can choose case 1. And then then I'm going to break this case just like this. So any function that I'm going to put here will be considered as for case 1, right? So maybe you can say case 1, enter case 1 for adding what is maybe something like that. So let me here say maybe it's to make it is for me, guys, wasande zvakachipa. Wasande zvakachipa. Let me just say int maybe some, let me put 0 there, and then let me put A and B. Okay, not some here. Let me just say result. Result. Okay. So what I'm going to do is I'm going to have a program maybe to add, to divide, what two numbers, right? So you are going to choose if you want to add, if you want to subtract, if you want, something like that. So what I'm going to do is I'm going to print the result. So let me just say results, for case 1, let me say result A plus B. But let me just put the values here just to not take much of time doing this. Maybe I was supposed to ask the user to enter the values. I'm not going to do that. Just going to add, separate what, something like this. And then let me just print out the result, something like this. Then I'll put result here. Nothing fancy. Let me do this. Then I'll say results is yes. Super. Then let me just, guys, I told you that as programmers learn to cut and paste, copy and paste. I'm just going to copy and paste it here. And then, guys, if you're going to put if you're going to duplicate your case, you're going to get an error like what I've done here. So I need to put case 2 here, and then maybe here I'm going to subtract. Maybe let me just B minus A. Let me just A minus B, just like that. And then the result, I'm just going to show it here. And then they see it after break. Then let me put case 3, maybe for division, something like this. Then I'll put the result. Super. Copying and paste, the art of copying and paste here. I'm going to put a default case. I'm not going to put this up. What is multiplication? No, not that one. So I'm just going to put the default case, and then I'm going to print out that, guys, I'm going to print out that maybe wrong input. That's the default case, wrong input. All right, boom. So guys, if you put any of the case, and if you put any number in choice, which is not case 1, case 2, case 3, you are going to get what do you call it? You're going to get this default. It's now the default case, and there's no need of breaking the default case unless if you put default inside here between among these cases. So if I run this, I'm going to get wrong input. Why? Because I've put 50 here. So to spice it, maybe I can say I can say system. Let me just say sys out. No. Then I can say and 1 for addition. I think it's 1 for addition. Then let me just put a slash in there. And then I'll say enter 2 for blah 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 blah, which is 2 for is for what? For subtraction, for sub. And then I can put another slash in there. Guys, I'm sure you know these things. Then I can say enter 3 for for division. There's no need of putting another slash in there. Let me see if I can get something nice. Okay. So now I need to take the input and then I'll put the value in choice. Simple, right? So here, let me just leave it without. That's
Sorry, sir.
yes.
Why you have initiated result as 0? Why?
Okay, this one, okay. I can even not put a value. It's just a value that I thought that because result is where I'm going to store the value after addition, after subtracting, after what. So it's just a value that you can put as a 0 there before doing anything. The result is 0, just like that. So it's a default value. You can decide if you know to put this, but if I didn't put any value there, it's going to be given a 0 by the default construct. Those constructs that we have learned there. So here choice, I've decided to not give it any value, but it is going to have a value there. So for me to how to get an input from the user using Java, I can use a class called what? Which class can I use from the user?
The scanner class.
The scanner class. Thank you. So I can have the scanner, then the scanner object input. So you got new scanner. All right. And then I can put system.in. It was slipping out of my head. Thank you. I need to import this one. Yes, I need to import this. Don't worry, Java will do it for you. I need to import this because it's a class which was already done in Java. So I just need to import it for me to be able to use it. Boom, it's already there. So now I'm using it. So I've asked the user to enter the input and then boom, I'm taking the input and put it in what? In choice. So I've said this choice is going to have input dot next integer next int. So that's what you do. Use the method called next int to get the integer from the user. For it to be smart, allow me to remove this animal. This is the art of cutting and paste that I've been talking about. You need to have this skill of copying and paste. Copy other people's code and paste it. But please know what you are copying, know what you are cutting and pasting. I know what I'm doing. So boom, if I can do this, yes. It's now waiting for me to enter. Yes. Now I can put maybe 20. Then it can say wrong input. I can run again. Then I can enter maybe 2. Then boom, result is minus 10 because I've entered 2, which is a choice of subtracting. Then it is going to choose the case 2, which is here. And then it is going to do what? It's going to subtracting, boom. And then I'll get a minus 10. Wow, nice. I can do what? I can do an addition, which is 1 for addition. And the result is that, which is 10 plus 20. So I'm going to get a 30. See, as simple as that, So that's how you can use the switch statement. You put anything which is not within the cases, it is going to run the default statement. Okay, let's say that it happens that you forgot to put a break statement on case 1, and then you run this and you choose case 1, right? What will happen? You see, result is 30, result is minus 10. It is going to run case 1, and if it doesn't see a break there, it is going to run the case 2 as well. So you always need your break here. Otherwise, you need to know the consequence of doing that. So that's it, guys, on the switch statement. I don't know if I've got questions on switch statement. If I do not have questions, thank you for your understanding. If I do not have questions, thank you for understanding. What else do we have? Can go on to what? I can go on to, okay, let's look at a while loop and a do while loop and a for loop. I guess these things, they are very, very simple. I'm sure there's no one with a challenge on these things. If you look at it, Java while loop, loops can execute a block of code as long as a specified condition is reached. So loops are handy because they save time, reduce errors, and they make code more readable. The while loop loops through a block of code as long as a specified condition is true. So guys, if you want to write, maybe it's a line of code, just one line of code, and want to repeat it maybe more times, then that's where you can look forward for loops. For example, you can have a simple code that can print from 1 to 10, right? Instead of repeating system.out.println 10 times, you can just write it once, and then you put some logic in your loop, and then you can print it from 1 to 10 by only one print out statement, just like that. It's not that cool. It's not that cool. Right? So that's where you can use loops. That's where you can use loops. So this is the syntax for a while loop. If you look at it, it's just the same while loop that you have been writing in C, in C++. That's why I have said that Java is as good as C, it's as good as C++, but I don't know most of it, but that's what it is. That's what it is. So this was an example of printing I from 0 up to 4, So this was iterating maybe 5 times, printing from 0 to 4. This is the code which is doing that. Well, that's the end of the slide. Easy peasy. So what you can do here, this code is too nice to be, but anyway, what can I do? Let me let it go. I hope this is, yes, okay. Okay, guys, so what I can do is I want to have a while loop. I'm just feeling that I can use this code later. Allow me to I think there's a shortcut to, let me comment this out, guys. Comments, I'm not going to talk about this. It will be something, comments. Let me just comment it out. So this will become comments, and it will be not going to be compiled when I'm going to run the next code. So let's act like this code doesn't exist. It's not there. So I'm inside my main method. I'm going to have a while loop. All right. So guys, while loop, what it does, it takes a condition. And if the condition is true, it is going to keep on looping in here. I'm not going to write this, but this one is an endless loop. It keep on looping this as long as the condition is true. If I put false, it is not going to run something, a boolean. The issue is that this is a dead code and an unreachable code. Why? Because it is not going to execute here, because there is always false. So you put a condition that can result into true or false, right? So let me have something like int I. I've just used I because it's the one that is actually used by most common programmers, right? So if you start to put M there, Dani foot. Let's make sure that we're always on mute. Let's make sure that we're always on mute. So guys, let's look at okay, I was saying while I want to say where I is less than 5. Let's just do what was sys out. All right. And then I'm going to print I. Let me print I. So guys, for a while loop, you need to put something here that can make this condition false. You need to put something inside that can modify to make sure that this condition is going to be false some later on. If you look at this, if I just put I less than 5 and do nothing here and keep on printing I, what is going to happen is that I'm going to print 0 till don't know. It is going to be infinite loop. Why it is going to print a 0, then is it I less than 0 less than 5? Yes, it will print 0 less than 5. Yes, it will print. So you need to keep on looping here. So you need to put maybe something like I is equals to I plus 1, which is increment I by 1, right? Which is in short is just I plus plus, the increment operator, right? All right, after doing this, it means it is going to print from 0 to what? To 4. Why 0 to 4? At first, city 0 less than 5, yes, print 0 here, and then increment I by 1, which means it's 1. 1 less than 5, yes, print 1, increment by 1. 2 less than 5, yes, increment, then print and increment. 3 less than, yes, print and increment. 4 less than, yes, print and increment. 5 less than 5, no. So inobva in the kunzoka no print as not yautoita zvinotera nditi aunomhanya code inotera just like that. So if you want to print maybe from 1 to 5, you need to put less than or equal to here. Then boom, the code is so simple and easy, just like that. So that's how you use the while loop. So there are a lot of ways that you can use, there are a lot of scenarios that you can use a while loop in real life projects. Maybe you want to make sure that a person always put the correct password for you to execute the next what you can put a while here. Then you can say maybe while the password is equal to whatever, and then you keep on asking, enter the password. Then if you put the wrong, you'll be in that cycle. Otherwise, maybe after some time, we can just say, boom, we block your pin, whatever. So you can use the while loop. That's some of the scenario you can use a while loop. I don't know if I've got some questions on the while loop. If there are no questions, do I have questions, contributions? No. So the while, let's look at a do while. So a do while loop, we are guaranteed that the code inside the while loop is going to execute once, at least once, right? Why? Because you are saying do this something, then you put the condition later. So the do while loop is a variant of the while loop. This loop will execute the code block once before checking if the condition is true. Then it will repeat the loop as long as the condition is true, just like that. So yeah, so you say do, then you put the code, and then you test the condition, just like that. For example, here you can say print all this, then you check, then also while I is less than 5. So it's obvious that it is going to print this at first, and then it will increment, and then it will check later. So yeah, it is obvious that this code is going to be executed at least once. Why? Because the condition is after it has been actually doing some calculations there. So that's the do while loop. I don't know if I've got questions on this one. I can demonstrate here. I can take this out, right? And I can put do here. Do this, and then I can put the while condition here. That's what you're supposed to do. And then you have to terminate here. And then I can run. And then you can see that I'm going to get the same output. Okay, I'm going to get the same output. So guys, it's as good as I can take this code that I've been, let me spice it. I can take this code that I've said, I'm good at cutting and pasting. Let me cut it out. All right. Oh, nice. Let me cut it out. Then I'm going to take this. All right. I've put all my code in here. Do this. All right. Let me just leave it in here. All right. So I want to say here, maybe my I is equal to 0 here, right? And then I want to say, well, I maybe is equal to 5, right? Yeah, where I is equal to 5. So this one, where I is equal to 5. This is the equal sign. Okay, thank you. So what I'm going to do is, after doing this, I want to ask the person if they want to continue, right? So I want to say, if please enter something like, something like that. So if you want to continue, or I say to continue, enter 5, right? And then I will say to exit enter any number, right? And then what I'm going to do is here I'm going to take the input from user. So instead of put I plus plus here, what I'm going to do is very simple. In I, I'm going to put the input. I already have the input object from the scanner object, input scanner object. Then I'm going to take the next int. These are the methods which are already in what? Let's come on. I just want, so next int. Just want, yes, this one. Don't want to type things, you know. Yeah. So after this, yes. So I'm going to run. They need to ask me, enter one for addition, what, blah, blah, blah. Then I'm going to say, okay, I want to add, right? They need to ask me, right? Result is state. Then they ask me, enter, to continue, enter 5, to exit, enter any number. Then I say, okay, I want to continue. Let me put 5. Then I say enter. Then you just ask me again, what do you want to do? I want to subtract now. Okay, enter 5 to continue. Now I do not want to continue. I'll put 6, then boom, it takes it. So maybe here I can say this out just to show that all right. I can say you know, I can say what? Okay, I can say exit. Boom. Yeah. So I can do this. Division, the result is 0. Okay, then I can put maybe 2. I want to exit, then okay, but exit, something like this. So guys, I've put the do, and then I'll do this code. As long as I is equal to 5, I'm going to keep on doing this code or doing this work. So as long as you are putting 5, it will keep on looping this code. But if you put any number, because we are just putting the condition that I must be equal to 5 for us to keep on looping. So if you put any value there, which is an integer, then boom, it is going to 1. You know, so that's what it is with the do while statement. I don't know if I've got questions, contributions. Okay, I've talked much. What you can do, there is the for loop. So guys, what I'm going to do is for the for loop, let me see. Maybe I just have 2 slides. I can finish on the for loop, and then we can start on OOP. I'll suggest tomorrow, but guys, you need to keep watching because I do not really know my schedule for tomorrow. So if I'm going to be available tomorrow, maybe it's around 6 o'clock, 6 p.m. But it's hard for me. So if you are not going to do it tomorrow, you're going to do it on Monday. We need to finish on OOP on the next tutorial, and then we focus on other modules, or we do some revision and then focus on other modules. So let's just quickly finish on this. These are just 5 slides. Bear with me, guys. I know you want now to cook. You want, there are a lot of things, You want to go for a sport, today it's a sport day. Yeah. Vamwe want to bet and it, Yeah. So let's look at for loop, Java for loop. So the Java for loop is used to iterate a part of the program several times. So if the number of iterations is fixed, it is recommended to use a for loop. And it's just like the while loop that I've been using. You can use it to account the same thing. But if you know the exact number of conditions, the number of iterations, go for a for loop. So a simple for loop is the same as the C and C++. You can initialize the variable, check the condition, and then increment or decrement value. Just as good as that. So here you've got 4 for the first statement, second statement, and then the third statement. For int I is equal to 0, I is less than 5, and then I plus plus, then you'll be printing the value of I. So what happens here, guys, is very simple. This is the initialization. Our I is going to start from 0. After that, you check if I is less than 5. Then you do what you are supposed to do here. After that, you increment, then you check, and then you do what you want to do. You increment, you check, you do what you increment, you check, you do what you want to increment. So you only come here once. You only come here once, and then you check, and then you get in here, You increment, you check, you increment, you print, you increment, you check, you do what you want to do, you increment, you check, just like that. So that's how a for loop operates. So you just need to get that logic. Like this one, by mere looking, you can see that it is going to iterate from I is equal to 0 till when I is equal to 5, but when I is equal to 5, it's not going to print 5. Why? Because 5 is not less than 5. So it is only going to iterate from 0 to 4. So it is going to print from 0 to 4, something like that. So that's all on a for loop. Maybe to demonstrate this one, I can do what demonstrate this one, what I can do. Say for loop. Now I can take this whole code out. No longer need it. We are no longer friends. We are no longer friends. We are no longer friends. Okay. What I'm going to do is very, very simple. It's a for loop. Okay. Let me just say already. All right. Let me just remove all this here. Guys, I've told you that be good at copying and pasting, cutting and pasting. It will save you a lot of time in programming. Some of the things you'll be repeating. Int I, and then you say I is less than 5. And then you terminate, because we have said this is the statement, the second one is the statement. So you are going to terminate, and then I plus plus. And then you can also say I minus minus. It's just a matter of how do you want your loop to execute. So here I'm going to say this out. Then what else? I'm going to print I. Let me just print I. Let me just keep it simple, keep it cool. It is going to print it from 0 to 4. Why? Because I've said from I is equal to 0 and A must be less than 5. So it will be keep on looping here, looping. What if I say I minus minus? What am I supposed to do if I do this? It means that I need to start from a higher value going down till I must be, maybe let me just say I must be greater than 0. This is greater than 0, right? So it is going to print from I is equal to 5 till to I is equal to 1. That's right. 5, 4, 3, 2, 1, right? Because I must be greater than 0. So you can use the decrement operator or the decrement operator or any code something that you want to put here. So that's what it is on a for loop statement. I don't know if I've got some questions on a for loop. Questions, contributions. Seems like now, someone's saying. Okay, so if there are no questions, guys, on our next tutorial, we are going to start on encapsulation. You know that encapsulation is one of the OOP concepts. It's one of the object-oriented program concept. We only have 4 concepts. So encapsulation is one of that. We've got abstraction, we've got polymorphism, we've got inheritance. So we need to cover all that on our next tutorial, which is supposed to be tomorrow. But guys, if I do not make it tomorrow, I will announce it maybe 3 hours before, so that people can prepare for that time. But guys, I am not sure. So keep on checking with me. If you do not do it tomorrow, let's try Monday. I'm sure I'll be around for this one. Can do it quickly, and then so that we can focus on other modules. But guys, keep on revising. I don't know if I've got questions. If I have questions, I don't know if I've got questions. Let me stop recording. Questions, contributions.